Alright, good afternoon class. So I hope you have already finished all the homework before this. Alright, so please if you have any question, please WhatsApp me and let me know, okay? Alright, so today we will continue 4.7. Before this, we have discussed how to express a complex number in Cartesian form, which is x plus yi. Alright, so today we will going to see how to express a complex number in polar form. So why we want to express it in polar form? Definitely we have reason, right? Because when we express a complex number in polar form, then some calculation will become easier. Alright, so we will see it one by one. Okay, so 4.7, complex number in polar form. Okay, how we express a complex number in polar form? Okay, let's say consider a general complex number z equals x plus yi. This is Cartesian form, represented on an Argand diagram by line OP, where P has Cartesian coordinates xy from the real part and the imaginary part xy, and the polar coordinates are theta. We call r theta as polar coordinates. Alright, so what is r and what is theta? So refer to this diagram. Alright, so this is the Argand diagram, right? Let's say point P with coordinate xy represent the complex number z, which is x plus yi. Alright, and we join the point to the origin. Alright, so we know that the length of the line OP will be the modulus, right? Modulus of z, which we represented it by r. So r is actually same as the modulus of complex number z. And theta is the argument. Theta is the anchor measured from positive x-axis to the line OP. Alright? So you get this idea what is r theta. So if it is in Cartesian form, then we call it Cartesian coordinate xy. If it is in polar form, then we call the coordinate polar coordinates, which is r and theta. R and theta. Alright? Okay, so let's look at this one. This is when z is expressed in Cartesian form. So we know that r is actually the modulus of z, which is the length of line OP. And the formula is square root x squared plus y squared. Alright, and theta is the argument of complex number z, where the formula is arc tangent y over x. Right? So now we are going to see how we are going to change from Cartesian form to polar form. Alright, so let's look at the diagram again. Because this is coordinate xy, so we know that this horizontal distance is x and this vertical distance is y. Alright, so from the diagram we can see cos theta. So this is theta. Cos is adjacent hypotenuse, x over r. Alright, so when we shift r to this side, so x is equals r cos theta. Whereas sine theta, so this is theta, sine is opposite hypotenuse. Right, therefore sine theta is y over r. So again, we shift the r to the left hand side, so we get y equals r sine theta. See? So from the diagram, we get x in terms of r and theta. So x is r cos theta, whereas y is r sine theta. Alright, so from this Cartesian form, x plus yi, so we substitute. So now we already get x is r cos theta plus y is r sine theta and I. Alright? Excuse me. Alright, so we factorize out r. So normally we write in this way r cos theta plus I sine theta. Normally in polar form, we can put the I in front of sine theta. Alright, so that sometimes students will write like this one, it's like quite confusing whether this I is belongs to the theta or what. So normally in polar form, we can write I in front of sine theta. Alright, so again, remember this is Cartesian form, this is polar form. Alright, so some you can see some overseas book, they call it modulus argument form. Modulus argument form. Why? Because from this form, we straight away can get the modulus and the theta argument. So we also call it modulus argument form. Alright? Okay, so now let's see. if we express a complex number in polar form, how we are going to do the multiplication? By quite fast, quite simple. All right, so this is a process. Just show you how to get it. So in exam or in exercise, you can straight away use the formula. All right, so multiplication of complex number in polar form. Okay, let's say I have two complex number. Z1, okay, is R1 cos theta 1 plus I sin theta 1. So for complex number Z1, the modulus is R1 and the argument is theta 1. Alright, then Z2. Alright, this one, so modulus Z1 is equals R1, argument Z1 is equals theta 1. Okay, and then the second complex number is Z2 with modulus R2 and argument theta 2. Modulus R2, argument theta 2. Alright, so when we multiply Z1 and Z2, means we multiply this one and this one. Multiply this one and this one. So R1 multiply R2. Alright, and cos theta 1 plus I sin theta 1 will multiply with cos theta 2 plus I sin theta 2. Alright, we just write it together. Alright, so this R1 and R2 will remain here. So we are going to expand this one like quadratic. Alright, so you see cos theta 1 multiplied cos theta 2. Alright, yeah. Then they arrange like this. They arrange like this. Okay, cos theta 1 multiplied cos theta 2. Then I sin theta 1 multiplied I sin theta 2. But like plus plus. But I is I square. Remember, I square is negative 1. Therefore, it's minus here. So sin theta 1, sin theta 2. They put it together first. Because we know that cos minus sin is what? This is trigo identity, right? Cos minus sin is cos A plus B. Cos minus sin, so become cos theta 1 plus theta 2. Alright? Then the next one is sin theta 1 cos theta 2. So sin theta 1 after multiply with this one also need to multiply with this one, right? So sin theta 1 cos theta 2. Alright? With I. Okay, got I. Then the next term is, just now cos theta 1 already multiplied with cos theta 2. So cos theta 1 also need to multiply with I sin theta 2. So got I also lah. So I cos theta 1 sin theta 2. Cos theta 1 sin theta 2. So both term also have I. This one multiplied, this one have I. This one multiplied, this one also have I. So I factorize up the I. See? I factorize the I. So become sin cos plus cos sin. So sin cos sin is sin A plus B. Alright? So sin cos sin becomes sin theta 1 plus theta 2. Alright? So this is when we multiply two complex number in polar form. So we will expand like this. Then we use the trigo identity. Two trigo identity. One is for cos A plus theta. One is for sin A plus cos A plus B. Another one is sin A plus B. Alright? So therefore, alright, so remember when Z1 multiplies Z2, it becomes a new complex number. Alright, this is a new complex number. It's a product. Alright, therefore you see that the modulus and the argument of the complex numbers Z1, Z2 means for this new product, alright, will be very simple. You see this new complex number, the modulus, very simple. Just multiply the two modulus of the complex numbers that we multiplied together. Alright? So, or we can write it as modulus Z1 multiplied modulus Z2. Or else the argument is theta 1 plus theta 2. 1 plus 1 multiplied. Modulus is we multiply the modulus of the two complex number. Argument is we add the two arguments together. Alright? So means that when you are asking to multiply two complex number in polar form, you don't have to go through all this process. No, you don't have to go through all this process. You just use this formula to find the new product. You just use this formula to find the new modulus and the new argument, then just sub into the polar form. You don't have to go through all these steps. Alright? Is that clear? Alright, so this is a conclusion for what we have done here. So conclusion is, when you multiply two complex number, its modulus will be, you multiply the corresponding modulus of the two complex numbers. And the argument is, you add the two argument. Alright? And to find the product of two complex number, multiply their moduli and add their argument. Multiply their moduli and add their argument. Alright, this is how we can do multiplication of two complex number in polar form. Oh, it's very easy, right? Even if it is in Cartesian form, you still have to multiply, expand it, then only you get the answer. But if in polar form, surely we can get it. Alright? So this is for polar form. So this is for multiplication. Alright, so how about division? Alright, how about division? One thing before this. So this is multiplication and division, right? So maybe you will ask then, teacher, how about add and plus? Same law, add and plus, you just add and plus the corresponding terms or the real terms and the imaginary terms, just as usual. Alright, that's why we don't specially explain here. Alright, so we will go to the division. Alright, so how we can get the formula to do division in a faster way in polar form? Alright, again, let's say we have two complex numbers, Z1, Z2 with R1, R2 and theta 1, theta 2. Alright, so when we divide these two complex number, so this is Z1, this is Z2, we divide it. Alright, so remember, if the denominator is a complex number, we'll multiply its conjugate of the denominator. Not included R1, R1, R2, no need. That's why you see R1, R2. After that, I put it outside already. We look at the trigo part only. Alright, so we are going to multiply with the conjugate of this one. So cos theta 2 plus I sin theta 2, the conjugate is cos theta 2 minus I sin theta 2. Over conjugate over conjugate, which is 1. Alright, which is 1. So we don't change the value of the original equation. Alright, so R1, R2 is just a number, so we put outside. So remember, conjugate multiply conjugate pairs is just square the first term and square the second term. Add it. Square the first term and square the second term and plus. Again, remember why plus? Because I have I square. So I square is negative 1. So multiply with negative, become plus. Alright, then numerator you expand as usual, like just now. Alright, so cos theta 1 is going to multiply with cos theta 2. You get this? So sin theta 1 will multiply with sin theta 2. This one multiply this one, you get this. Okay, because you have I square, which is negative 1. So plus, multiply negative, you get plus. Alright, then sin theta 1 going to multiply with cos theta 2 also, this one. And minus cos theta 1 going to multiply with I sin theta 2 also. The last two terms have I. This one multiply this one have I. This one multiply this one also have I. So I factorize out the I. See? I factorize out the i's, then it becomes sine, cos, cosine. Alright. Okay, so again, we are going to use the trigo identity. So this is cos, cos plus sine, sine. So the identity is cos theta 1 minus theta 2. Okay, and this one again is sine, cos, cosine minus. So it's sine theta 1 minus theta 2. I lah. See? Alright. So after we have expand, then we get this. Alright, so next will be therefore. Therefore. Okay, you can see that from here. Okay, I show it here. Okay, so I show it here. Just now we found that after we divide two complex number, we get it. So this is a new complex number. Again, this is another new complex number with the modulus is R1 over R2. See that? The modulus of this new complex number Z1 over Z2 is R1 over R2. Or you can just write modulus as Z1 over modulus Z2. Whereas the argument for this new complex number is theta 1 minus theta 2. This one. This is the argument. This is the modulus. Alright? So conclusion is when you divide two complex number in polar form, So you can just find this new complex number by finding the modulus, which is the modulus of the first complex number over the modulus of the second complex number. Then the argument is you minus the complex number. Remember when come to minus z1 minus z2 means the up one have to minus the down one. Don't reverse. All right. So to find the quotient of the two complex number, divide their moduli, means this one, and subtract their argument, this one. Alright, so I hope you are clear how to multiply two complex number in polar form. So we just expand. For multiply, we just expand and we get it with trigonometry identity. Whereas for division, we need to add one more step, which is multiply with the conjugate over conjugate. Then only we expand. So this one, cos square plus sine square is what? Cos square plus sine square is 1. Alright, that's why it disappeared. Okay, so this is the useful of polar form. So when we have complex number in polar form, we can do the multiplication and the division in a very simple way. Alright, of course we have other usage also other than this. We are going to learn in 4.8 that one. Okay, alright, so we are going through some examples. Alright, so we will go through some examples. Alright, so example 4.7. Okay, so we discuss some simple one first. Alright, example 4.7. Okay, expressed in the form of r cos theta plus r sin theta I. Means in polar form. You are given in Cartesian form, so you are asking to express it in polar form. Okay, 1a, 2. This complex number, just 2. So you know that if a complex number is equals to a real number, means it is 2 plus 0i, right? So the modulus is 2 2 plus 2 square plus 0 square square root is 2 Argument is arctangent y over x. 0. So arctangent 0, 0 Okay, therefore in polar form is modulus, okay, cos argument plus modulus sine argument, then bracket I. So even though it's a real number, but yet we can write it in polar form. Okay, B, negative 5i. Just now, just only the real part. So B is only the imaginary part. Alright, so if only imaginary part actually is equal to 0 plus 5i minus. Okay, 0 minus 5i real part is 0. Imaginary part is minus 5i. Alright, so I sketched the diagram, remember? So that you can get the argument correctly. So y is minus 5. X is 0. So here, this is the line. This is OP. Okay? So if the point is here, means the argument is negative. And this is 90 degree. Okay? Modulus is 5 . So argument is negative pi over 2, 90 degree. Okay? Therefore, Z in polar form will be modulus cos theta plus modulus sine theta. Okay, we better put the sine theta in bracket, then multiply with I. Alright, this is something special, you see. When the argument is negative, when you learn trigo, still remember this? Cos negative theta, same as cos theta. Sine negative theta, same as negative sine theta. We are using this here. So cos negative pi over 2, same as cos pi over 2. Alright, whereas sine negative pi over 2, same as negative sine pi over 2. Negative sine pi over 2. So from here you know when you see a complex number in polar form and you see minus here, suppose it's plus, right? Suppose it's plus. And when you see minus here, so you know that your argument is a negative angle. Alright? Okay, C, I want you to do as homework because it's quite simple. Alright, I will go through D. D is 7 minus I divide 3 minus 4i. This one. So again, we go back to division of two complex number. Alright, so first step, we multiply conjugate. Alright, so when you multiply conjugate pairs, so 3 square plus 4 square. Alright, then this one expand as usual. So you have 25 over 25 plus, this one also 25, 25 over 25i. So it's 1 plus I. You see this is 1 minus I, C is 1 minus I, so D is 1 plus I. Alright, so modulus of Z is square root 2. And the argument, both also positive, so I know that it is in first quadrant. X1, Y1 is here. So positive angle lah. Arctangent 1 is pi over 4, 45 degree. Therefore, in polar form is modulus Z2. So now I factorize out Z2 lah. Cos pi over 2 plus I sine pi over 2. Alright? So you can put your I in front. Or you want to put the I at the back. So if you put the I at the back, it's better for you to bracket whatever in front. Alright? So this one, we do it by using normal way. We multiply first, we divide first. Okay, expressed in Cartesian form. Then only we find the modulus and argument so that we can write it polar form. Alright? Now, we can use the formula. Remember this formula? We can use this formula and see how to do it. So means that I do it separately. Okay, I find Z1 first. This is my Z1. This is my Z1. So modulus is square, 7 square plus 1 square, so 50. 50 is 25 times 2, right? So 5 square root 2 lah. Alright, argument is, because Y is negative. I write here lah, very simple, very fast. Okay, so 7, negative 1, so it's here. So we know that it is negative angle. Alright, so arctangent negative 1 over 7, Y over X. So it's, you calculate lah. Okay, you please calculate yourself. I didn't count. Okay, you calculate yourself. Okay, then Z2 is the denominator, Z2. Alright, so modulus is 5, 3, 4, 5 ma. Argument is arctangent negative 5 over 4. Okay, you also please count lah. Okay, you calculate yourself. Then, when we want to divide them, Z1 over Z2, right? The new complex number is Z1 over Z2. So the new modulus for Z1 over Z2 is modulus Z1, this one, over modulus Z2, this one. Alright, so 5 and 5 simplify, you get square root 2. Same, right? You see? Same. Alright, whereas argument for this new complex number, argument for Z1 over Z2 is, we multiply their argument, right? So argument Z1 minus argument Z2. Alright, so you calculate. So it's supposed same as pi over 4. Same as pi over 4. Alright, therefore, we get the new modulus and new argument, then we can write it in polar form. See? So when we are doing division of two complex number, okay, we have two methods and we want to express it in polar form. One do it like Cartesian way, then only find the modulus and argument. Another one is we do it separately as our Z1, Z2, find the modulus and the argument, then apply the formula to find the modulus of the new complex number and to find the argument of the new complex number. Use these two formula that we have just learned. Okay, then just write it in polar form. Okay. Alright, so this is question 1. Okay, next we will go to question 2. Alright, so just now you are given Cartesian form, then we change it into polar form. Okay, how about if you are given in polar form, then they want you to change it to Cartesian form. This one very simple, right? Just calculate sine and cos only. Alright, so you are given 4 cos 2 pi over 3 plus I sine 2 pi over 3. Just calculate. Use a calculator. Alright, so 2 pi over 3 is 120 degrees. 120 degrees is in second quadrant. Alright, I show it lah. It's here. 120 degrees. This one, 2 pi over 3. Okay, it's in second quadrant. So the acute angle is 60. This is 120, so this is 60. So cos 60 is half. And second quadrant cos negative. See or not? Or I think you press calculator also, they give you the correct answer lah. Okay, whereas sine 60 is square root 3 over 2. So in second quadrant, sine still positive. So I is here. Okay, so 4 multiply in. Therefore, this complex number in polar form. After we calculate, it become Cartesian form. So it's negative 2 plus 2 square root 3i. Alright? So this one no problem. This one quite simple. Okay, we will go to question 3. So represent the following complex number by a line on Argand diagram. Determine the modulus and argument of each of the complex number. So one they give you in Cartesian form, one they give you in polar form. Okay, 3a, this one. Let's say this is z lah. Let's say this is z. Alright, so expand it lah. Expand it become I power 3 plus I power 4. Still remember I power 3 I power 3 is I power 3 is negative I. Okay, I power 3 is I power 2 multiplied I. So I square is negative 1, remember? So this one, this is this one. Okay, I power 4. I power 4 is I square, I square. So negative 1, positive 1. This one become real. This one complex. Okay, this one, this one is this one. I power 4 is positive 1. So when we express in Cartesian form, it's 1 minus I. X1, Y negative 1. So here. So they just want you to, okay, write the, draw it in the Argand diagram. Then modulus, calculate lah. And argument. Okay, because it's in here, right? So it's negative anchor. Alright? B, you are given in polar form. So when you see this one, negative, so you know that it is negative anchor. Alright, so this is 150 degree. 150. 5 pi over 6 is 150. So 150 is come here already lah. Okay. Alright, so it is, so represent this in Argand diagram. Alright, then we calculate lah. We calculate. So in this third quadrant, cos negative ma. So cos 30 is square root 3 over 2. And this one also. In third quadrant, sine also negative. So sine 150 is half. Alright, modulus is 3. Okay, so multiply in, so you get this in Cartesian form. So because this is expressed in polar form, straight away you can see your modulus and the argument. Alright, no need to calculate. Okay, so question C, I want you to do as homework. And question 4 also, please do it as homework. This is STPM 2014. This is only part of the question. The question is quite long. So the first part is you're asking to express the complex number square root 6 minus I square root 2 in polar form. Alright, so please do it as homework. Alright, I will go to question 5. This is STPM 2015. Alright, so you see that the question say the complex numbers Z and W are given by this and this. Actually, first part we have done. This first part we have done before. You are given Z is minus 1 plus I and W is I plus Z 1 minus IZ. Alright, A, find W in the form of X plus YI. Find W in Cartesian form where X, Y are real number. Then state the real and imaginary part of W. This one we have done. You can refer back. Okay, in part 4.2.3, you can check example 4.2.3. So we have simplified this one and we found that W is actually equals I. W is actually equals I. I means 0 plus 1 I lah. So from here you can get the real and imaginary part, right? Real part is 0, imaginary part is 1. This one we have done. You can refer back 4.2.3. Okay, we are going to see B. Also, actually similarly to STPM 2014. Alright, express W in polar form. Another 3 marks. Okay? So W is I ma. So X0, Y1. So here, this is the point. Represent the W. Alright, 0, 1. This origin, this X. Okay? So from here, we are very clear that modulus is 1. Okay? And 90 degree. Positive pi over 2. So when you have modulus and argument, so straight away you can write in polar form. So W is, because modulus is 1, right? So 1. So actually, you want to write or you don't want to write, doesn't matter. Alright, and argument is pi over 2. So cos pi over 2 plus I sine pi over 2. That's it, 3 marks. Oh, express W in polar form. Just like this, 3 marks. So you don't just write your answer lah. Right. You sketch a diagram, you show your modulus and argument, then only you write this. Or else how to get 3 marks, right? Okay. Alright. Okay, so next is what is this? Okay, next. So question 6, STPM 2016. Yeah, I want you to do it as quiz. So right after this lesson, only one question, one quiz. Please complete it and forward into the Google Drive. I found that every time, not all of you pass up your solution. Alright? There must be someone that haven't. I will do a list. I will do a list to find out who haven't do any of the quiz. Please follow the timetable. Do it. Complete it. Alright? It's already first week of November. We don't have much time. Alright? We still have 2 long chapters. Chapter 5, conics, and chapter 6, vectors are quite difficult. Okay, we need more time to do it before your holiday. Alright, so I hope that you really follow and do complete everything on time. Alright? Okay, so I want you to do question 6 as quiz, then you forward it into your Google Drive. So this is STPM 2016. You are given complex number W and you are given complex number Z and W. Z is -1 minus I, W is 1 plus I squared 3. They just want you to express Z and W in polar form. That's it. Okay, 5 marks. So I want you to do it as quiz. Okay, question 7 is checkpoint 4.2. Please complete all these questions which related to polar form. Okay, so remember last time when I discussed STPM 2018. Alright, page 9. You can refer back to your notes, page 9. This one. Okay, in example 4.68. Example 4.68, question 2. Alright, so that question that question page 9, so let me check where is page 9. 7, 8, 9, 10. Okay, where okay, 9, 10 here. Okay, page 9, STPM 2018. Where is it? Hold on, let me see. Here. Example 4.6a, STPM 2018. Alright, complex number Z has modulus 8 and argument 2 pi over 3. They give you modulus and argument. They want you to find the real and imaginary part of Z. Alright, so by that time we are using this method. Okay, remember I told you there are 2 methods to do this. Method 1 is polar form. Method 2 is normally they give you modulus, they give you the modulus, they give you the so from here we get one equation. Then hold on, let me check where is the solution. 4, 6, 1, 4, 6, 1, 4, 6, 2. Okay, here. Alright. So they give you modulus. So we use modulus formula, we get one equation. Then they give you argument. We use argument formula, then we get y and x. From here we get another equation. Then we solve 2 simultaneous equation. We solve 2 simultaneous equation to find x and y. Alright, to find x and y, then we can find the real part and imaginary part. This is Z. Okay, then we find real and imaginary part. This is the Cartesian way. All right. So now we see, since we already learned polar form. Okay, so let's see how we can do this question in polar form. Where is it? Okay, 2018. Oh, okay. One, two, three. Yeah, here. Okay. This question. You see, if we can do it in polar form, even faster compared just now. Okay. So remember just now they give you modulus of z, then they give you argument of z. All right. So since we have modulus and argument, we express z in polar form. See that? We express z in polar form, then we calculate and get the Cartesian form. Just calculate and get Cartesian form. So when we get Cartesian form, we straight away find the real part and imaginary part, right? Compare just now. Just now definitely longer lah. Just now we have two equation, right? Z square plus y square equals 8. Then get this one. Then solve simultaneous. This is longer. All right. So if you do it in polar form, it's just very short only. See? All right. Okay. So for this part, I will stop here. All right. So please go through, then complete the quiz. All right, and forward it to the Google Drive. Then you start do your homework. For other questions that I ask you to do as homework. All right. So if today we still have time, then I will continue part of power and roots of complex number. Okay. So we have to complete this one in by this week lah. So I will see first, see whether it's long or not. Okay. If long, then I divided it 4.8 to 2 videos. Okay. Then you have to do it in Friday and Saturday like that. Okay, so make sure this week you must complete all the homework for this chapter. Next week we are going to start chapter 5. All right, because remember our kerja khusus is related to chapter 5. All right. Okay, thank you class.